Welcome back, everybody. So today we're going to look at multiplying binomials and trinomials and, well, any kind of omial. We're going to look at it and we're going to see, hey, that's the same thing we've been doing since we've learned to multiply back in like second or third grade. I know it seems strange with all those x's and those little exponents tucked away in the corner, but it's actually the same thing we've been doing for a long time. It just looks a little different. So let's take a look at it. All right, so let's look at an example of how we oftentimes see multiplying polynomials in our math class. So we're oftentimes given something like this. Here's a pair of binomials, the quantity 4x plus 6 times the quantity 2x plus 2. And then we're oftentimes taught to do the FOIL method, which stands for first, outer, inner. I probably could have written this differently, but what the heck. Inner, and then last. So that means the first, so the F stands for the first, so the first term, so it's 4x times 2x. So that gives us, let's see if I know my multiplication correctly, that's going to give us 8x squared. And then the outer numbers, if you're looking at it, it's the outermost term, so it's 4x times 2. So that gives us plus 8x. And then the inner terms, which are the two innermost terms like this, so we get 6 times 2x, which is plus 12x. And then, let's see, then the last one is the last in each binomial, the last term in each binomial, so 6 times 2, which is 12. And then we have the x squared term, these two x terms, and then our constant, so we can just sum our like terms together. So we get 8x squared plus 20x plus 12. Okay, great. So we've multiplied this pair of binomials. We get this trinomial. Great. So this is how we're oftentimes taught in math class. And I mean, as a teacher, I've done it. I've taught it this way before. But I always think it's important to connect our work that we're doing in math either back to something we've previously done or something that you will be doing later. So we're going to connect this method back to something we did way back in like third grade or whenever, I can't remember exactly off the top of my head, when we first learned to multiply 2 and 3 digit numbers together. But this is exactly what we did when we learned to multiply. So let's look at an example. We're going to call this example 1A. We're going to go back in time. So we're going to do 46 times 22. We're going to multiply these two numbers together. And so we're going to go through this step by step, just like how we did when we were taught initially, or how most of us were taught. Those of us who were born in the 1900s were oftentimes taught this way. So we start with the units. So we go 2 times 6 is 12, but the 10 we carry to the next 10, we regroup it. So then we get 2 times 4 is 8, which is actually 80, plus one more 10 is 90. There we go. And then now we're playing with this 2, so that's actually not 2, that's 20, so we have to account for the tens placed there. So then we get 2 times 6 is 12, regroup that 10 back up to here. Then we get, again, 2 times 4, which is 8, plus 1, which is 9, but that's actually 900. We do that, and then we add these terms together. We get 2. We get 90 and 20 is 111. Or, no, whoa, hang on, back up there, Salvin. 110, pardon me. And then carry that one up there, so we get this. So we get 1012. Great. But this is exactly what we did here. We did the units place, the 2 times 6, We did that, and I chose these numbers to make them to match pretty well. 2 times 6, 2 times 6, here's the last terms. And then we did, let's see, then the 2 times the 4 here, but this 2 is that 2, and this 4 is that 4 right there, 4x. And then here we've got this 2, which is actually this 2x, and then times that 6, and then 2 times that 4, which is actually 2x times 4x. So the whole point of this is for you to see the connection between what we're doing in math class with multiplying polynomials and how that connects directly with our work with just multiplying numbers. So I'm going to rewrite this so that it looks like our example here. So instead of laying them on the same line like we do in class, I'm going to stack them. And I'm going to stack them in such a way that we get the constants over one another and the like terms over one another, which is actually, if you look at it, it's very similar to what we did here. Here's the 6 and the 2, the units, 6 and the 2 is the units, 4 and the 2 here, that's actually the tens here. So then we're going to multiply, this is crazy. We're going to multiply these binomials in the same way we multiplied this pair of 2-digit numbers. The same thing. 2 times 6. 12. 2 times 4x. 8x. 2x times 6. Well, let's see. 2x times 6 is 12x. And then 2x times 4x gives us 8x squared. Sorry, it's kind of light. And then, just like in the previous example, we're going to add these together. This is a 0, because when we take the 2x times 6, it's not a constant, it has an x term. So we get our 12. Here's our 20x. And then we have our 8x squared. Look at that. So we did the same thing. And something I want you to notice is that this 4 is the same thing as this one, except this 4 has been multiplied by 10. So in other words, this x could be replaced by 10, and we should get the same thing. So let's see, we're going to basically substitute 10 in for x. And then we crunch these numbers together. Let's see, that's 10 squared, it's 100 times 8, that's 800. And then here, 20 times 10 is 200. And then 12. And if I know my addition, 800 plus 200 plus 12 is 1012. And look at that. It's the exact same thing. That's pretty cool. Multiplying binomials is the same as when we multiply 2-digit numbers. All right, so there you go, people. So the point of this video was to show you that when we're doing some of these multiplications with polynomials, it's the same thing as what we've been doing when we've been multiplying 2 and 3 and 4-digit numbers, any number of digit numbers that we want, but it just looks a little different. And so that's the point of this video, is to make the connection between what we're doing now in high school math or college math and what we've learned as elementary students, and how they're actually one and the same. They just look a little different. All right, I hope you enjoyed it. If you have any questions or comments, post them below, and we'll see you next time.